here. Right, so now I'm going to share the screen. Okay. I don't think you see the board yet, right? Where's the board? Oh yeah, here. Okay, okay. Okay, perfect. So then all I need now is to click on the chat so I can see your messages here. Okay, perfect. Okay, so let's start, guys. So this is still same section. So this is section. So this is section 1.7. All right. So let me just remind you quickly because I think some people didn't make it yesterday. So I'm gonna just remind you quickly in few words what we did yesterday. Um, so yesterday we said we can do algebraic operations on functions. So we do algebraic operations on functions. And again, what I mean by algebraic operations, so it's just addition. So it's just the usual operations, right? So addition, subtraction, multiplication, and division, right? Multiplication and division, right? So so let me just remind you the notation we had. Notation, right? So first for the sum, second for subtraction, and then of course a product or multiplication, and then division. All right, so the sum, the notation for the sum would be like, so f and g of course are two functions. So we have f plus g of x, and we said that would be f of x plus g of x. Subtraction, it's f minus g of x. So that's f of x minus g of x. Multiplication, it's with a dot, f dot g of x. So that's f of x times g of x. And finally, division, we write like f over g of x, and that means that's f of x over g of x. Anyway, so this is the notation. So that's the notation, right? Now, so yesterday I talked about the intersection or the common domain. So we had and then we had the common domain or intersection domain, right? And so we used the following notation. So we said, let's say, so D subscript F. So let's say D subscript F is the domain of F. D subscript G is the domain of G. Then we said DF with reversed capital U, right? DG, that will be the common domain of F and G, right? And actually, we had a couple of examples yesterday on how to find this common domain, right? And I said at the end of the lecture that we are interested in this common domain because of the following theorem. So we had I think at the I mentioned at the end of the lecture the following theorem. So I said, so here's a theorem. So the domain, the domain of f plus g. Okay, f minus g, f times g is domain of f intersected with the domain of G, or the common domain to F and G, right? And domain of F over G of F over G would be is domain of F or the common domain to F and G with values of X where G is 0 are excluded, right? With values of X where G of X is 0 are excluded. So that's like a summary of what I said, what we discussed yesterday, right? Now, so let me do an example, show you how to, again, find this common domain. So here's an exercise. So, or an example for the exercise. So example. So let's say example. Okay, so let's say f of x is 1 over, let's say, 3 minus x, right? And g of x is square root of, let's say, x plus 4, right? So the question is, find domain of f plus g, f minus g, f times g, and f over g, right? So I want to find the domain of f plus g, f minus g, f times g, and f over g. All right, so here to answer this question, guys, you don't have to compute the f plus g, f minus g, f dot g, etc., or f over g. Okay, all you have to do is to use the theorem. So the idea here is to use our theorem. So the idea is to use the theorem, which says that use the theorem, right? So the theorem says the domain of f plus g, f minus g, here, domain of f plus g, f minus g, and f times g would be just the common domain, right? So all I have to do is to find this common domain, right? So if you want to use the theorem, then all you have to do is to find, so we have to find the common domain, the domain of f intersected with the domain of g, right? So, and then we said yesterday, actually, to find this common domain, there are mainly 3 steps. So there are 3 steps to follow. So 3 steps. So step 1, you need to find domain of f, find df, d subscript f, find d subscript g, and then we can find the intersection domain, right? So, so let's follow these steps. Once you find this common domain, then that will be the domain of f plus g, f minus g, f times g, all right? But then f over g, we need to exclude the values where g is 0, all right? So let's first do these steps. So for step 1, I want to find domain of f. Step 1, want to find the domain of f. So f of x, f of x is 1 over 3 minus x. All right. And I said yesterday, as a reminder, so if you have division, all you have to do to find the domain is to solve the bottom equal to 0. And if you have a square root, then you have to solve the expression under the square root larger or equal to 0. So let me just quickly remind you here. So if you have division, you have to solve the denominator equal to 0. And if you have a square root, right, then all you have to do is to solve the expression under the square root larger or equal to 0. So the expression under the square root larger or equal to 0, right? So like here, f is, so like here, f, it's a fraction, of course, so it's a division. So all I have to do is to solve the bottom equal to 0. So we need to solve, of course, guys, please, feel free to ask questions, interrupt me and ask questions, all right? Yeah, so I was saying here, this is a division, it's a fraction. So all I have to do is to solve the 3 minus x equal to 0. So then, of course, x would be equal to positive 3, right? So then the domain of f would be any number except the positive 3. So the answer would be, so domain of f, so then domain of f is any real number except the 3, because again, because if x is 3, then the bottom would be 0, and we are not allowed to divide by 0. So this would be negative infinity, positive 3, union. So this capital here, of course, means union, right? So this is positive 3, positive infinity, right? Now, the step number 2. Now I have in the step number 2, I have to find the domain, find d subscript g. That's the domain of g, right? So that's, so g of x is square root of x plus 4, all right? So it's square root of x plus 4. And let's add plus 1 here just for fun. Or no, okay, let's just keep it. But yeah, so it's just the square root of x plus 4. And as I said, if you have a square root, then all you have to do is to take the expression under the square root, the x plus 4, and solve x plus 4 larger or equal to 0. And again, if you have something else outside this, outside the square root, then you don't really care about it, right? It's only about the thing you have under the square root. Okay, everything outside the square root doesn't matter. So we have to solve this x plus 4 larger or equal to 0, right? You subtract 4, of course. Then, of course, so then x is larger or equal to negative 4. So x has to be a number which is larger or equal to negative 4, which means it's on the right side of negative 4, right? So the domain of g would be negative 4, positive infinity. Negative 4 is included because x can be equal to negative 4, and infinity, of course, is always excluded. Now, we are almost done. So now I can find my common domain. So step 3, I want to find df intersected with dg, right? So again, my advice, guys, it's the best thing to do is to draw a number line. So let me draw a number line. So first, let me remind you. So we said df, domain of f is negative infinity, positive 3, union with positive 3, positive infinity, right? And domain of g, we said it's negative 4, positive infinity, right? So as I said, to find this common domain, the best thing is, unless you are an expert, but the best thing is to draw a number line, all right? So, and this is the number line, of course, it goes from negative infinity to positive infinity, right? And then you have to put the numbers you have, like here I have 3, right? So I'm gonna put 3. And then here I have -4, so I'm gonna put -4 on the left side of 3 because, of course, -4 is less than 3, right? Okay, so now once you have a number line, you can draw your domains. So let's start with domain of f. Domain of f is any number except 3. So it's like the whole number line except the positive 3, right? So that's df. So it's in red. Now domain of g, it starts at a -4. So here it starts at -4, -4 included, and it goes all the way to all the way to positive infinity, right? So that would be the domain of g. So domain of g is in green, domain of f is in red. So the common domain would be the domain or the interval, which is at the same time red and green. So which interval is at the same time red and green? That would be the common domain, of course. So it would be, from, here from -4 all the way to positive infinity, except, of course, the positive 3, because, positive 3 doesn't belong to the domain of f. So it's not in the domain of f. So it's not common to the domain of f and domain of g because it's not in the domain of f, right? So, so the common domain would be this yellow domain. So this is df intersected with dg, right? So it would be like, it's going to start like at -4 all the way to positive infinity, except the positive 3. So the answer here, so this intersection domain or common domain, so df intersect with dg from -4 to, I have to exclude the positive 3 again, guys, because it's not the domain of f, union, right? Then 3 positive infinity. Okay, and again, guys, keep in mind that between whole numbers there are decimals. So so you need all the intervals here. So you need the interval from -4 to positive 3. It's not just because like there's a -3 or -2 in this interval. I mean, there are infinite number of numbers between -4 and 3, like decimals, fractions, etc. Right? And of course, you need the 3 positive infinity. So we have a union of 2 intervals. So that's the intersection domain. So is there any question, guys, before moving forward? Is there any question about how I got this intersection domain? I guess probably the question is, for people who missed the lecture yesterday, any question? Okay, no questions. Well, good. Then, so yeah, so we almost got our answer. So now I can, so our final answer. So we can say, so domain of f plus g, f minus g, f times g is -4, 3 union with the positive infinity. All right. Now, of course, there's f over g still missing, right? Well, f over g has like a special treatment because we need to exclude the values where g of x is equal to 0. So, so here, remark. So for f over g, we have to exclude where g is 0. The values of x where g of x is 0. Okay, so what we have to do now for f over g is solve. All we have to do is to solve g of x equal to 0. So I need to solve g of x equal to 0. And g of x, of course, is, we said g of x is square root of x plus 4, right? So So we need to solve square root of x plus 4 equals to 0. All right. So how do we solve such equation? Well, there's the square root, so it would be a good idea to get rid of the square root first. So all we have to do is to take the square here, the square here. So then that will be x plus 4 equal to 0, right? And then of course x would be negative 4. So for the domain of f over g, all we have to do is to exclude this negative 4 from the intersection domain, right? So we have to exclude x equal to negative 4 from the intersection or the common domain, right? So now I can write down my answer for f over g. So the domain of f over g is, so you see guys here, this is the this is your common or intersection domain, right? The negative 4 is included, right? Now for f over g, so what I'm saying is you have to exclude the negative 4, right? So then the answer would be negative 4 excluded, right? 3 excluded, of course, union with 3 positive affinity, right? So again, here's the difference. For f over g, you exclude the negative 4. For f plus g, f times f minus g, f times g, the negative 4 is included, right? That's the unique difference between domain of f plus g, f minus g, f times g, and the domain of f over g. Is there any comment, any question, any remark? Okay, perfect. So then here's an exercise, a similar exercise where we have to find domain of f plus g, etc. Right? So exercise, I can probably move to the next page if it's okay with everyone. All right. So let me.
1 minute.
Oh, okay. That's why I was asking. Okay, perfect. So I have to go to the bottom here. Okay.
Yes.
Perfect. Okay. Okay, so I can write my exercise right here. So an exercise. So of course, in this exercise, you need to find the domain of f plus g, f minus g, f times g, and f over g of. So first, so let's have like two different problems. So first one would be, excuse me? Okay. So first one, it would be, let's say, f of x. So f of x equals to 2 minus x over x minus 3. And g of x is square root of x plus 5. And x plus 5 plus 1. So here, sorry, x plus 5. So not 5. Let's change the 5 here, and let's say it's 25. Oops. So let's say it's 25 here, right? And then we do have minus 5 right here. Minus 5. Okay, so it's square root of x plus 25. X plus 25 is under the square root, and then there's minus 5. And number 2, f of x is square root of x plus 1, right? And g of x is x plus 1 over square root of 9 minus x minus 3. Okay. So I hope everyone can see the bottom of the board here. Okay, yeah, so you have a couple of minutes, guys, to think about this exercise. Yeah, and I'm here, of course, to answer any of your questions. Any guess for number one? So what would be the domain of f plus g, f minus g, f times g?
Professor?
Mm-hmm.
Yeah,
Yeah.
you said you wanted to know the answer of f plus g, f minus g, and f times g?
Yes, please. Yeah, for number one.
Uh, I think I have included negative, yeah, included negative 20 and 3, union 3 plus infinity? Positive infinity, I mean?
Negative 20 or negative
Yeah.
25?
I had negative, I had negative 20. Unless I wrote that
Mm-hmm.
wrong.
How did you get the 20?
Because g of x was x plus 25 minus 5.
Mm-hmm.
I'm trying to look exactly. All right, yeah, I had
Oh,
x.
you,
Yeah,
you subtract 25 minus 5? I mean,
yeah, and I got 20.
no, you cannot do that. Actually,
Okay.
it's PEMDAS rule says that you have the square root. So the square root applies. So you have the square root x plus 25 under the square root, right? So we're supposed to apply the square root first to the x plus 5 and then subtract. All right. So you cannot just subtract the 25 minus 5. And anyway, for the domain, I said all you have to do is take the expression under the square root. So you don't really care about the
Oh, okay.
minus 5, all right?
Okay.
But
Okay.
still, I mean, PEMDAS rule says you cannot combine. You cannot combine the 25 and the 5. It's not 25
Okay.
minus 5 there. It's a square root of x plus 25, right? And then there's the subtraction. Mhm.
Okay.
Um, Al-Mu'tasim, you're saying for the first one, I got f plus g is equal to 3. Okay, so Al-Mu'tasim, the question here is not, is not to compute what's f plus g or, f minus g. You don't have to compute, the algebraic expression of the f plus g, etc. Right? So the question is about to find the domain. And as I said earlier, I mean, if you want to find the domain, you don't have to compute anything. All you have to do is to find the common domain, right? So, uh,
Professor,
yes. Mhm.
I get negative 25, 3, and then 3 and positive infinity.
Yes, that makes, yes, that's correct. That's very good. Yes. So again, guys, the problem here is not about computing, the algebraic expression of f plus g, f minus g, etc. It's about finding the domain. And you want to find the domain, you need to find the intersection domain, the common domain.
And then in that situation, do you also want us to also find what f over g is for number one as well, or no?
Yes, yes, please.
Okay.
Mhm. So be careful. Number two, it's more tricky. I mean, especially for the domain of G, right? Because the domain of G, there is a division. So and it's not just a fraction, but you do have a square root there, right? So in the function G, and then problem number two, in the function G, you have both. You have division and square root. So Bavasir, you are saying domain of F is negative 1, 9. Uh, You mean probably negative 1 positive infinity. Right, I guess you mean negative 1 positive infinity. That would be the domain of the function f in the problem number 2. Yes.
Hey, Professor. I mean, is the I found the domain of f and
Intersection domain?
yeah, intersection domain for the second one.
I'm not sure. I mean, I don't really have the answer. I have to solve the problem, but I
All right.
really doubt that would be the fine answer.
All right.
So domain of f is going to be negative 1 positive infinity. Domain of g would be
Minus infinity and 9.
less than 9. Oh yeah. I think you're probably right. Yes. You're right. You're almost right, actually, because you have in the domain of G, you have also to, G is also a division, right? So you have to exclude the values. You have to solve the bottom is equal to 0 in G. And the bottom would be 0 actually when x is 0. So I think your answer, you have to exclude the 0.
0, yes.
Yes. Yes. Yeah, actually, you're correct. Yes. Yeah, you're right. All right, guys. Sorry, I don't have much time, so we have to go move forward. So, okay, so let me go quickly over this exercise. So for number 1, okay, so for number 1, as I said, you don't have to do any operations here. You don't have to compute f plus g or f minus g, etc. All you have to do is to find the intersection domain, because that's what the theorem says, right? So, so for number 1, so first you have to find the domain of f. So f is 2 minus x over x minus 3. So it's a fraction. So you have to solve the bottom equal to 0, right? So then x is positive 3, and so domain of f, it's any real number except the positive 3. Now for the g, so g is, so here be careful, guys. This is the square root x plus 25, and then there is a minus 5 outside, right? And of course, I mean, the square root, it's like, it's a power. So you have to do the power first and then subtract. So you cannot really here simplify. You cannot really subtract, 25 minus 5. Anyway, so we have a square root, right? You don't have a fraction, you have a square root, and the expression under the square root is the x plus 25. You don't care about the minus 5. So all you have to do now is to solve x plus 25 larger or equal to 0, right? And again, we don't care about the minus 5. And so then x would be, of course, larger if you subtract 25. So then x would be larger than negative 25. So then the domain of g would be so x is any number larger than negative 25. Negative 5, so this is negative 25, positive infinity. Negative 25, of course, is included, and then positive infinity is always, as usual, excluded. right? So we are almost done. Now I can find domain of the common domain. I can find the common domain. So here's my number line. F, I have 3, so I'm gonna put 3 on the number line. And in G, I have negative 25, so I'm gonna put the negative 25. So for the domain of F, it's any number except 3. So this is the domain of F. And then domain of G, it's any number larger than negative 25. So negative 25 included. So here's negative 25, and then any number larger than negative 25. So the common domain would be, of course, in this case, the domain, I mean, the interval, which is at the same time red and green. So that would be so this interval here would be my intersection domain, except, of course, the 3, right? Because it's not in the domain of F. So it's not a common to the two domains, right? So then find the answer for domain of F plus G, F minus G, F times G is, so that will be this yellow interval. So it starts at negative 25, goes all the way to positive infinity, except the 3. So we have to exclude the 3, right? And so that will be the answer for F plus G, F minus G, and F times G. Now, for F over G, so for F over G, we need to solve, we have to solve G of X equal to 0. So let's see where G of X is 0. So G of X is square root of X plus 25 minus 5 is equal to 0. So I have to solve this equation here. And then the idea is to exclude the solutions. You have to exclude the solutions from the common domain. And that will be the domain of F over G. So let's solve this. Well, you can add plus 5 both sides. So that's square root of X plus 25 equals to 5. All right. Get rid of the square root. So let's just apply the square both sides. All right. So then you're going to have X plus 25 equals to 25. And of course, you subtract 25. So then your X would be 0. So what I'm saying is to get the domain of F over G, all you have to do is to exclude the 0 from the intersection domain. So so here's the answer. So we have to exclude, so exclude 0 from the intersection or common domain. So find an answer here. So domain of F over G is, so I'm going to exclude 0 from the common domain. So 0 is between, it's between negative 25 and 3, right? So so then it's, so we're going to have negative 25 to 0, 0 excluded, then 0 to 3, both excluded, union with 3 positive infinity. All right, so this is a little bit different from the previous, the example we had, because G of X here, you have to, there's this minus 5 outside the square root, so it changed, a little bit the solution of G of X equal to 0. But anyway, so that would be the domain of F over G. Is there any question, guys, about this this problem number 1? So you see how it works, right? Okay, so yeah, so let me do the problem number 2 very quickly. So number 2, so this is here, let's say, okay. For number 2, So as usual, step 1. So where's your f? And number 2, f is square root of x plus 1. Okay, so square root of x plus 1, f of x, square root of x plus 1. So so we have a square root, and so we have to solve the expression under the square root. So we have x plus 1 under the square root, so we have to solve x plus 1 larger or equal to 0. Right, so then x would be larger or equal to -1, and domain of f, it's any number larger than -1. -1 is included because x can be equal to -1, so it's -1 positive infinity. Now, step 2. So domain of G. So let's see what G is. So G is, where is it? Number 2. It's actually x plus 1 square root of 9 minus x minus 3. So G is x plus 1. G is x minus 1 over square root of 9 minus x minus 3, right? Let me just check again. X plus 1, sorry. It's x plus 1. So, and it makes a difference actually. We'll see why. So x plus 1 here. So here, g of x, it's a fraction. So if it's a fraction, it means we have to solve the denominator at the bottom equal to 0. So first thing to do is to solve the bottom equal to 0 because it's a fraction. So we have to solve this 9 minus x minus 3 equal to 0. That's the first thing to do. A second thing to do is, because there is a square root, right? A square root of 9 minus x. So we have to solve, this 9 minus x larger or equal to 0. So we have to solve 9 minus x larger or equal to 0. Right? So there are two things to do here. It's not just one equation. Here we have two equations. So let's solve the two equations, right? So if you solve, let's say, so first, let's say you solve the 9 minus x larger than 0. So if you do plus x, then 9 would be larger than x. So the number x must be less or equal to 9, right? So 9 is larger than x, larger or equal to x, right? So your x must be less or equal to 9. So here x is less or equal to 9. All right. Now that's the first. That's the inequality. Now we're gonna solve the other equation, the square root of 9 minus x minus 3 equal to 0. So they have plus 3. So it's the square root of 9 minus x equals to positive 3. You apply the square. So then 9 minus x would be equal to positive 9. So all you have to do now is you can, for example, subtract 9, so minus 9 here, minus 9. So then you're going to have minus x equals to 0, right? And of course, minus x is equal to 0 if you divide or multiply by -1. Okay, so then x is equal to 0. So then x is equal to 0. So we have two things here. First, my x is less or equal to 9, right? And x cannot be equal to 0. So I have to exclude this value, right? Because that's when the bottom is 0. Okay, so the domain of G would be so domain of G. So domain of G would be, so X first is less or equal to 9. So that would be like from, from, I mean, you can put draw a number line if you want. So let me do it here, number line. So here's my number line. So let's say here's 9, here's 0. This is negative infinity, positive infinity. So what I'm saying is X is less than 9 or equal to 9, right? But then we have to exclude the X equals 0, right? So we have to exclude this 0 here. So the domain of G would be like, so the domain of G would be like negative infinity to 0, 0 excluded, union 0, 9. 9 is included, right? So that's the domain of G. Now I can find a domain of the common domain. So step 3, a common domain. So let me just write it down for you for your convenience. So the domain of F, we said domain of F is -1 positive infinity. So it's -1 positive infinity. Domain of G, it's a negative infinity 0, union 0, 9 included, right? So, okay, so here's my number line. I'm gonna need -1. I'm gonna need 0, and I'm gonna need positive 9. And of course, here you have the infinity, right? So now let's draw the domain of F. So domain of F, it's -1 positive infinity. So here's the domain of F, -1 included. Then domain of G, it's negative infinity to 0, 0 excluded, right? And then from 0 to 9, 9 is included, right? So what will be the common domain? What will be the intersection of these two domains? So what will be the interval which is at the same time green and red? Well, so you can see here it's green and red. It's green and red here. 9 is included. The -1 here is included. However, the 0 is excluded from the domain of G, right? So it's not in the domain of G, so it's not common to the domain of G and F. So the common domain would be, so df intersected with dg would be like -1 included, 0 excluded, then 0 to positive 9. So now that's the common domain. So that would be the domain of F plus G. So domain of F plus G, F minus G, F times G is this -1, 0, union 0, positive 9. Positive 9 is included, right? So that's, we are almost done. All you have to do now is to find the domain of F over G. And as I said, in F over G, you have to avoid the values where G is 0. So now, so for F over G, we need to solve G of X equal to 0. So we need to solve G of X equal to 0. G is, I think it's X plus 1 over 9 minus X. That's all under the square root. I think so, 9 minus X. And then there's minus the outside here, right? That's my G of X. And I need to solve this. Let me check again, sorry. For G is, where's G? Yes, yeah, it's x plus 1. Yeah, I'm correct. Just to make sure that that's correct. So it's x plus 1. Perfect. So then, so yeah, so I need to solve this equal to 0, right? So we have a fraction equal to 0. So if you have a fraction equal to 0, it means you have to solve the top equal to 0. Okay, so this is like a general rule. So if a fraction is 0, a fraction is equal to 0, then it means that the top is 0. Okay, because if the top is 0, 0 over a non-zero number is just 0. So all you have to do, you don't really care about the denominator. All you have to do is to solve the numerator equal to 0. So all I have to do is to solve the x plus 1 equal to 0. Okay, so x plus 1 is equal to 0. Okay, subtract, so x is negative 1. So I have to exclude the negative 1 from the common domain to get the domain of f over g, right? So you see here in the domain of the common domain, you have negative 1 is included. So you see here, this is included, the domain of f plus g, f minus g, f times g. Now for f over g, so domain of f over g is, so negative 1 is going to be excluded, right? Because that's where my g is 0. So this is excluded 0. Sorry, negative 1, 0. Union 0, 9 included. Right. So that will be the domain of f over g. Right. Okay, guys. Is there any question? Any remark? Any observation? Nope. Okay. So yeah. Okay. So that's good. So we are done actually with the operational functions. Now, so we're gonna move like to a different let's say subject. So now we're gonna discuss the composition of functions. So I can probably move to the next page unless someone is not didn't finish with the writing down the notes. So I'm gonna just move to the next page. So yeah, so now let's move to the composition, the second part of the section, the composition of functions. Okay. So we're gonna we're gonna compose functions. So let me show you an example how it works. So what does it mean, composition of functions, right? So so let me start with an example.
Professor,
Yes.
sir, can you return? Give me 1 second.
Oh, okay, sure. The bottom here.
At the bottom.
And actually, it's a lot.
Little bit up.
Is that what you are?
The one down, I'm not seeing good.
The one at the bottom here.
Yeah. It's okay.
Okay.
Yes, thank you.
Sure, no problem. So the composition of functions, guys, we're gonna compose functions. Excuse me. So we're gonna compose functions, and so we'll see how it works. And then the goal would be to find the domain of this composition of functions. Okay, so this composition of functions is like a different operation. It's not an algebraic operation. It's not addition or subtraction or multiplication or division. It's just a different kind of operation that we can do on functions. So I guess I can move to the next page now, Ibrahima.
Yes, you
Okay,
can.
thank you.
Thank you.
Perfect. So yeah, here's an example. So let me explain first what I mean by compositional function. So let's just take any function, and like let's say f of x is x cubed minus 2x squared plus 3x minus 4, right? So what I'm gonna do, so I'm gonna play a little bit with this function f. So what I'm gonna do, I'm gonna just, instead of x, let's say we have x squared, right? So I'm gonna put, so here I'm gonna compute f of x squared, right? So all I'm saying, guys, is that whenever you have x, so this x here, x becomes x squared, right? So whenever you see x, so then that will be x squared. So like, so this would be equal to, so you see here, I have an x in here, an x in here, and an x in here, right? And what I'm saying is those x's, they're gonna be replaced by x squared. So this x here is gonna be replaced by x squared, this is an x squared, this is an x squared, right? So this x here is going to be x squared. And of course, there is the cube, right? There is still a cube, power 3 here. See the power 3 here? So we're going to put power 3 here, right? That's the same thing. And then we have minus, then we have 2, so minus 2. And then I have my x here, and I said instead of x, we're going to have x squared. So I'm going to put x squared here inside the green circle. And then there's a power 2 outside, right? The green circle. So I'm gonna keep the same power 2 plus 3, all right? And then x, I'm gonna replace this x, of course, by x squared. So here's an x squared, and then there's minus 4. So what I did, guys, is just whenever you have x, whenever we have x, we replace it by x squared, all right? So this f of x squared would be equal to, actually, so this is x squared cube, right? So first, you need to think of the green circles as parentheses. So this is like x squared parentheses cube minus 2, x squared parentheses square minus 3 parentheses x squared, and then minus 4. All right. Now, guys, remember the power rule. I mean, if you have x to the power a to the power b, x to the power a to the power b, that will be x to the power a times b, right? So like this f of x squared would be actually x powers x squared cube. That would be x to the power 2 times 3, right? So that would be 6 minus 2 x squared squared, that would be x to the power 2 times 2, that would be 4. Here it's just minus 3x squared. There's no, it's just, there's only one power, and then there's minus 4. So I got, you see here, I got a new function. So this is f of x squared. It's a new function. So this is a new, it's a totally different function, right? It's a new function here. This is a new function. Okay, so all I'm saying is that so you can replace this x by any, by anything. Here I replaced x by x squared, but I can replace x. Oh yeah, thank you, Carly. It's plus 3. Thank you. It's plus 3. Sorry. Yes, thank you. So what I'm saying, guys, is that you can replace the x by anything. So for example, instead of x squared, so let me write again f of x. So we have f of x, x cubed minus 2x squared plus 3x minus 4. So I can, for example, instead of x squared, I can replace this x by, let's say, x plus 1. So here, instead of x, we're going to have x plus 1. So anytime you have x, whenever you have x, you're going to replace it by x plus 1. So here, this x here is going to be x plus 1, x here, x plus 1, here this x plus 1, right? So it's going to be like, this is going to be x plus 1, and I'm going to keep the same powers, of course. This is cube here, then this is minus 2, x plus 1, is square plus 3, this x plus 1, and then minus 4. So this f of x plus 1, so this f of x plus 1 is going to be, and again, guys, you need to think of the circles like parentheses. So this is actually x plus 1 parentheses cube minus 2 parentheses x plus 1 square plus 3 times parentheses x plus 1 and then minus 4. And of course here I get like a totally different function. This is a new function, right? So this is a new function, and of course you can try to, you know, simplify the distribute, you know, all the terms here. So this is of course a new function, right? Anyway, so so you see the idea, guys, is you have a function f, f of x, and you can replace x by, you know, by anything. You know, like here I replace x by x squared or x plus 1. It could be anything, right? So it could be any function g actually. So the idea is, so we start with f of x. So we start with f of x, f of x, a function, right? Then what we can do is we can replace x by another function. Let's call the function, let's call g of x. So you see, I can replace my x. Instead of x, we're going to have g of x. And that will be a new function. So f of g of x is a new function. So okay, so then so this f of g of x has a name, and it's actually called the composition of two functions, right? So so f of g of x is called the composition of two functions f of x and g of x. Okay. And so we have a notation for this f of g of x. So notation is the following. So here's a notation for this f of g of x. So let's say you have two functions, f and g. So let f of x and g of x be two functions. Then, so f of g of x is denoted by f and then a circle g of x. So this f, so this is a new notation here. So this circle here, or this empty dot here, means composition. Okay, this is a composition. So this f of g of x is the composition of f of x with the g of x. So that's the composition of f of x with g of x. Okay. Okay, so here's an example, more examples. So example, right? So let's say f of x is x squared minus x plus 1, right? And g of x is 2x plus 2x minus, let's say, 3, all right? So let's say you want to compute or find f of g of x, and of course you can also start with g, so g of f of x. Okay, again guys, this empty dot, it's not multiplication, this is what we call a composition, right? So this is, so be careful, you have to distinguish between the dot for multiplication and this empty, empty circle or empty dot, and this thing here means a composition, so it's not multiplication, right? So this is not multiplication, right? It's not a dot, it's not a product, right? So it's composition. Now, how do we find this f composed? So again, this circle here means composed, right? So f composed with g, or so this is here, this is f composed with g, right? So let's compute this. So my f of x, so my f of x is, x squared minus x plus 1, right? Now I want to compute f composed with g. So I want to compute this thing here, f composed with g. So we said this should be, so this is the notation for, you see here, this is the notation f composed with g. That will be f of g of x. So that's f of g of x. So it means you replace x. You see this x here. So you need to replace your x by g of x. Okay. So whenever you have x, so here's an x, right? There's another x here, right? So whenever you have x, you need to replace the x by g of x. All right. So this x here is going to be g of x. So this thing here is going to be g of x. And we do have another x right here, and that will be also g of x. So this is also a g of x, right? Then and then I can I have, of course, there's a square. There's this square here. This is a square here. So I need the square here minus. So here's my minus. That's the g of x, and there's a plus 1. So here's my plus 1. And it's plus 1 there, and so I do have a plus 1. All right. So now, so what I'm gonna do, I'm gonna just compute this thing. So so my f of, so let me write it down here. So my f of g of x would be, as I said, it's, you think of the circles as parentheses. So we have this yellow circle around g of x, so there'll be parentheses. So that's like parentheses g of x squared minus parentheses g of x plus 1, right? So now let's just replace g of x. G of x is 2x minus 3, right? So it's like 2x minus 3 squared minus parentheses 2x minus 3, minus 3, minus 3, and then there is a plus 1. So again, that's my f composed with g. So now we can do the computation, right? We can try to simplify this thing here. So 2x minus 3 squared. So it should be like 2x minus 3 times 2x minus 3. And then we have like minus, and then I can distribute the sign. So it's minus 2x plus 3, because minus minus, that would be plus, and then there's plus 1, right? So let's just compute this. 2x minus 3 times 2x minus 3. So that will be 2x times 2x is 4x squared. minus 2x times 3, that's minus 6x, minus another 3 times 2x, so that's another 6x, and minus 3 times minus 3, that will be plus 9. You see, so what I'm saying, guys, is so we have to distribute this thing here and then the 3 here. All right, so then we have minus 2x plus 3 plus 1. So now I can simplify. So f of g of x. So let's count how many x squared. We have 4x squared. So that's 4x squared here. Now, how many x's? We have minus 6x minus 6x. That's minus 12x. Minus 2x, that will be minus 14x. So that's minus 14x. Now the constant, we have plus 9 and plus 3. That will be plus 12, plus 1. That will be plus 13. So plus 13. All right. So that will be the final answer. That will be f composed with g. All right. So any question how I got this f composed with the g of x? So you take your f of x, all right, like here, you write down your f of x, and then the idea is to replace each of the x's, so like this x here and this x here, right, by g of x. Okay, and then of course, and then you can try to simplify your equation, right? So that's for f composed with g, right? Now, if you want to do g composed with f, okay, so that's f. So because of course there's a difference here. You know, this is f composed with g, but here this is g first composed with f. So g first. Okay, so now let's compute. So I'm gonna find g first composed with f. Right? So g is first, right? So if g is first, so I'm gonna write down g of x. So g of x, we said it's 2x minus 3, right? So it's 2x minus 3. 2x minus 3. Now I want to compute g composed with f. So g composed with f is g, and then between parentheses, g first, of course, and then between parentheses, we have f of x, right? So the idea is to replace each of the x's by f of x. You see, so this x here, it becomes f of x, right? So here in g, I only have one x, right? This one here, right? So all I have to do is to replace this x by, by my f of x. So we're gonna have like 2, and then inside this yellow circle, we're gonna have f of x, right? So it's minus 3. Does it make sense to you guys? So g composed with f, g first. Okay, you take g first, and then you replace your x by f of x. So whenever you have x, you replace by f of x. So now I can write down my g composed with f of x. So it's 2 times, so again, think of the circles like parentheses, like this is parentheses, 2 times parentheses f of x minus 3. So that will be equal to, so f of x is x squared minus x plus 1. So x, so this is g composed with f of x. So it's 2 times, so f of x, we said it's x squared minus x plus 1. That's my f of x. And then there's this minus 3 here. Okay, so let's distribute. So that will be like 2x squared minus 2x plus 2 minus 3. And here, there's only one simplification. You can subtract 2 and 3. So this is 2x squared minus 2x, 2 minus 3, that would be minus 1. So that would be a fine answer, right? So then you see it's, so that's you see that g composed with f of x is actually equal to 2x squared minus 2x minus 1. And you can see, guys, this is a completely different function from f. If you start with f, so you see here, oops. So if you start with f, f composed with g, it's 4x squared minus 14x plus 13. But if you compose g with f, if you start with g, okay, and then f, it's a completely different function, right? So this is so what I'm saying is g composed with f, this is not equal to f composed with g. It's a completely different function, right? So this is not equal. Okay. So the order of the functions is really important, right? Is there any question, guys? Otherwise, we can move to an exercise where we have to compute like a composition of two functions. So here's an exercise. So let's say exercise. So what you have to do is to compute or to find f composed with g of x and g composed with f of x. Okay, so let's say f of x. So let's say f of x is 8x over 1 minus x, and g of x is 3 over x. And of course, guys, when you compose the functions, you need to, simplify your answer, right? Once you have your f of f composed with g or g composed with f, then you need to, simplify your answer. Okay, guys, you have a couple of minutes to think about this exercise. And I'm here to answer your questions, of course. don't forget, guys, you need to simplify your answer. So if you have you have subtraction or have multiplication or wherever, right? So you have to you have to distribute or you have to divide or and so you have to simplify your equation. Crystal, you're saying for number, yes, I think you're correct. Absolutely. Yes, very good. I think it's the correct answer. Yes, the 24 over 3 minus x. I think it's the correct answer. Yes, very good, Crystal. So again, guys, here there are two different things to compute, right? So at first f composed with g, and then g composed with f, right? So it's like two different functions. So there are two things to do here, right? F composed with g and g composed with f. So again, guys, homework number 3 is due today, and I will post the homework number 4 tomorrow morning on Blackboard. Well, any guess for the G composed with F? Nope. All right. We don't have much time, guys. I mean, we have like around 5 minutes. Probably that will be just enough to go over this exercise. And of course, anyway, I mean, next Monday. So we're gonna meet next Monday, right? The usual time, and I will continue with this composition of functions. So we'll have, of course, more examples, and we can also use graphs, to find this composition of functions, etc. So yeah. So anyway, let me just go over this exercise in the last 5 minutes, and then we come back to this next Monday. Right. So so let's start with the F composed with the G. So first, so that's so we want to find F composed with G of X. So you have F first, right? So what you do is you write down F. So here's my F. It's 8x over 1 minus x. Right now, I want to compute F composed with the G, right? Which is, by definition, it's F of G of X. So instead of X, we're gonna have a G of X. So here's an X in here, an X in here, and all I have to do is to replace your X by G of X. So that will be 8. Oops. So we're gonna have an X in here and an X in the bottom here. So this is G of X, and here's G of X. So we're gonna have, so it's 8 times, so this is gonna be G of X, and then in the bottom we're gonna have 1 minus, and then we're gonna have G of X. All right, so it's gonna be F composed with G of X. So it's gonna be 8 times G of X. G of X is 3 over X. And in the bottom, it's 1 minus G of X, which is 3 over X. So guys, just be careful. I mean, when you have a whole number like 8, so when you write 8, it's like 8 over 1, right? I mean, so in the top here, you have a multiplication of 2 fractions. So when you multiply 2 fractions, you just multiply straight across. So it's like 8 times 3, so that will be 24. And in the bottom denominators, you have 1 times x, so that's x. So x times 1 is x, right? So that's 24 over x. Now, in the bottom, it's subtraction of fractions, because this one here, you can write it like 1 over 1, right? Any whole number you can divide by 1, right? It's going to be the same thing. So this is subtraction of fractions, so you need the common denominator. So if you need the common denominator, so which means that you have to, like, multiply by x. So that would be x over x in here, right? Minus 3 over x. So that would be equal to, so f of g of x. So we're gonna have 24 over x divided by, so here, once you have a common denominator, then you can subtract the top. So that's x minus 3, and you keep the same denominator, right? Which is x. Okay, so now this is a division of fractions. And how do we divide fractions? We need to flip the one in the bottom, right? So, so f of g of x would be like, so 24 over x times, and then you flip. Okay, so then you flip the x minus 3 over x. So that will be x over x minus 3. All right, so then you multiply. And so you see here when you multiply, guys, so that will be equal to, so your f over f composed of g of x, that will be 24 times x over x times x minus 3. So you just multiply straight across. But actually you can, there's an x in the top, there's an x in the bottom, because it's a multiplication, so then you can cancel out the x's, right? So then your f of g of x is actually 24 over x minus 3, and that will be a fine answer. Okay. Is there any question how I got this 24 over x minus 3? So you see, guys, there are a lot of operations you have to do here. Multiplication of fractions, subtraction of fractions. So you need to know how to do all these operations, right? And so that would be anyway. So that's the final answer. It should be, so it's 24 over x minus 3. Now let me just quickly in 10 seconds. Let me just compute g of f of x. Right. So your g of x is it's 3 over x. It's 3 over x. Now we want to compute g of f of x, which is g of f of x. So you replace x here by f of x. And in g of x, you got just, you have one x, right? So that will be your f in here. So that's 3 over, and then here you're gonna have your f, right? This is here is your f of x. So g composed with f of x is 3 over, and then f of x is where's f of x is 8x over 1 minus x. So it's 8x. It's 8x over 1 minus x. All right, that's your f of x. Well, this is this is like a division of fractions, right? So this is, here's the 3 here in the top, and the 3 in the top, you can write it like 3 over 1. Okay, so it's like 3 over 1 over, so it's division of two fractions. So you flip the 1 in the bottom. So then the answer would be, so g of f of x, it's 3 over 1 times, and you flip the 1 in the bottom, the 1 over x, 1 minus x over 8 of x, 8x. So you multiply straight across. So that's 3 times 1 minus 3 times x. So that's 3 minus 3x over 1 times 8x, which is 8x. All right, so that will be the final, that's the final answer. And that will be g of f of x. All right, guys, I'm sorry. I guess I went over time. Probably I solved this problem very quickly, but we will have time next Monday, to go over this again, right? We'll have, of course, more examples and etc. Okay, guys, I guess I'm gonna stop here. I will see you next Monday. Please don't forget your homework due today, and I will post homework number 4 tomorrow morning. All right, so I will see you next Monday. Take care and stay safe. Let me know, please, if you have any question, of course. Thank you. Thank you, guys. Have a good day.
For the notes, are they going to be posted?
Oh, yeah. Tomorrow morning, I'm going to post the notes of yesterday and today.
Thank you.
It's just because, we had 2 days in a row, and I have,
Thank you so much.
Sure, no problem. Okay, see you guys. Take care. Thank you so much.